Good day, my name is John Hubert P. Salas and this is my report in mathematics, and my report is all about Hamilton Plan. Hamilton's vision for reshaping the American economy included a federal charter for a national financial institution. He proposed a Bank of the United States modeled along the lines of the Bank of England. A central bank would help make the new nation's economy dynamic through a more stable paper currency. And apportionment and voting, a method of dividing a whole into various parts. This mathematical analysis has its roots in the US Constitution, specifically in 1790, when the House of Representatives attempted apportion themselves. The first method adopted in 1790 was the Jefferson Plan, suggested by the Thomas Jefferson. Thomas Jefferson and Jefferson Plan. First Secretary of State, Vice President, leader of the first political opposition party, and third President of the United States. Jefferson played a major role in the planning, design, and construction of a national capital and the federal district. The Hamilton-Vinton method. The Hamilton-Vinton method sets the divisor as the proportion of the total population per house seat. After each state population is divided by the divisor, the whole number of the quotient is kept and the fraction dropped. This will result in the surplus house seats. The first surplus seats is assigned to the states with the largest fraction after the original division. The next is assigned to the state with the second largest fraction, and so on. For example, if a country had 4 states and a 20 seats House of Representatives, this is the first state. The first state has 2,560 voters, and let's add the second state of 3,315 voters plus, and the third state is 995 voters plus 5, and the fourth state is 5,012 voters, and let's add them together and the answer is 11,882, and 11,882, let's divide into 20, is equals to 594.1. And this is the state population quotient, first allocation of seats, leftover decimal, seat appointed. And the set A has a 2,560 population, and the quotient is 2,560 divided by 20, and the answer is 594.1 is equals to 4.31. First allocation of seat is 4, and the leftover decimal is the 0.31, and the seat appointed is 4. And to the state B, the population of the state B is 3,315, and 3,315 divided by 20 is 594.1 is equals to 5.58. And the first allocation of seat is 5, and the leftover decimal is the 0.58, and the seats appointed is 6. And to the state C, 995, and the quotient is 995 divided by 20 is 594.1 is equals to 1.67. The first allocation of seat is 1, and the leftover decimal is 0.67, and the seats appointed is 2. And to the state D is 5,012, and to the quotient 5,012 divided by 20 is 594.1 is equals to 8.44. The first allocation of seat is 8, and the leftover decimal is 0.44, and the seat appointed is 8, and the total seats is equal to 20. And let's go to the next page, and this is the Jefferson method. The Jefferson method avoids the problem of an appointment resulting in a surplus of a deficit of house seats by using a divisor that will result in the correct number of seats being appointed. For example, if a country had 4 states and a 20 seats House of Representatives, 25 plus 3,015 plus 995 plus 5,012 is equals to 1182. 11,882 divided by 20 is equal to 594. The Jefferson method and the Hamilton method has a similar way of computing or calculating their method. And the state A is has 2,560 and the quotient is 2,560 divided by 20 is 594.1 is equal to 4.31 and the seats appointed is 4. And into the state B is 3,315 and the quotient is 3,315 divided by 20 is 594.1 is equals to 5.58 and the seats appointed is 5. To the state C is 995 and the quotient is 995 divided by 3 and the quotient is 995 and 594.1 is equals to 1.67 and the seats appointed is 1. And to the state D is 5,012 and 5,012 divided by 20 is 594.1 is equals to 8.44 and the seat appointed in the state D is 8 and the total is equals to 18 seats and 2 surplus. But if the divisor were 500 and this is the state A, B, C, and D and the population of state A is 2,560 and the quotient of the state A is 2,560 divided by 20 is 594.1 is equals to 4.31 and the seat appointed is 4. And to the state B, 3,315 and the quotient is 3,315 is divided by 20 is 594.1 is equals to 5.58 and the seat appointed is 5. And to the state C, the population is 995 and the quotient is 995 to 594.1 is equals to 1.67 and the seat appointed is 1. And to the state D, 5,012 divided by 20 is equal to 594.1 is equals to 8.44 and the seat appointed is 8 and the total seats is 18, 2 surplus. But if the divisor were 550 instead of 594 and this is the state A, B, and C, and D. The population of state A is 2,560 and the quotient is 2,560 over 550 is equals to 4.65 and the seat appointed is 4 and state B has 3,315 population and the quotient is 3,315 over 550 is equals to 6.03 and the seats appointed is 6. In the state C, the population is 995 and the quotient is 995 over 550 is equals to 1.81 and the seat appointed is 1. And to the state D, 5,012 and the quotient is 5,012 over 550 is equals to 9.11 and the seat appointed is 9. So the total seat is 20 because we need to the why 20 is because we add together the seat appointed is 9 plus 1 equals 10 plus 6 16 plus 4 is equals to 20. And this is the Webster method. The Webster method is a modified version of a Hamilton-Vinton method. After the state population are divided by the divisor, those with quotients that have fractions of 0.5 or above are awarded an extra seat. States with a quotient with a fraction below 0.5 have the fraction drop. The size of the House of Representatives is set in order to calculate the divisor, but can be increased in the final appointment if a large number of states have fractions above 0.5. If a country had 4 states and planned 20 seats House of Representatives, this is the 2,560 plus 3,315 plus 995 plus 5,012 is equals to 11,882 and 11,882 divided by 20 is over 20 is equals to 594.1. And this is the example of Webster method. In the this state B this must be a 3,315 and the answer here must be 5.58. So I'm sorry for the inconvenience, and let's proceed to the example. And the state A has a quotient of 2,560 divided by 594.1 is equals to 4.31. And the first allocation of seat is 4, and the leftover decimal is 0.31. Seat appointed is 4. And the state B has 3,315 divided by 594.1, and the answer is 5.58. And the first allocation of seat is 5, and the leftover decimal is 0.58, and the seat appointed is 6. And the state C, 995 divided by 594.1 is equals to 1.67, and the first allocation of seat is 1, and the leftover decimal is 0.67, and the seats appointed is 2. So, and letter D, state D is 5,012 divided by 594.1 is equals to 8.44, and the first allocation of seat is 8, and the leftover decimal is 0.44, and the seat appointed is 8. And if you add this seat appointed A, B, and C, the total number of the seat appointed is 20. And to get this location of seat, you need to, this is the answer of the first allocation of seat. This is 8, and the leftover decimal here is the 0.44. And the state is equals to 20 seats because we add this together, the A, B, C, and D. So this is the Huntington-Hill method. The Huntington-Hill method is a modified version of the Webster method, but it uses a slightly different rounding method. While Webster's method rounds as 0.5, the Huntington-Hill method rounds at the geometric mean, which is described below. If a state quotient is higher than its geometric mean, it will be allocated an additional seat. This method will almost always result in the desired number of seats. The geometric mean of two numbers is the square root of their product. For example, the arithmetic mean of 4 and 5 is 4.5. Why 4.5? Because 4 plus 5 is equals to 9, and divided by 2 is equals to 4.5. And the geometric mean is 4.47. 4 times 5 is equals to 20, and 20 divided by 4.47 is equals to 4.47. If a country had 4 states and a planned 20 seats of representatives, 2,560 plus 3,315 plus 995 plus 5,012, and the total of the population of the state is 11,882. And 11,882 divided by 20 is equals to 594.1. And this is the state population. And the state A has a population of 2,560, and the quotient is 2,560 divided by 594.1 is equals to 4.31, and the lower quotient is 4, and the upper quotient is 5, and the geometric mean is 4.47, and the seat appointed is 4. And to the set B, 3,315 is equals to 3,315, and the quotient is 3,315 divided by 594.1 is equals to 5.58, and the lower quotient is 5, and the upper quotient is 6, and the geometric mean is 58, and the seat appointed is 6. To the state C, the state C population has 995, and the quotient is 995 divided by 594.1 is equals to 1.67. And the lower quotient is 1, and the upper quotient is 2, and the geometric mean is 1.41, and the seats appointed is 2. To the state D, population 5,012, and the quotient is 5,012 divided by 594.1 is equals to 8.44, and the lower quotient is 8, upper quotient is 9 and geometric mean is 8.49 and the seat appointed is 8. And if you total the seat appointed, the answer is 20 represented, and then the total is 20 seats and